The world revolves around the constant cycling of matter with energy. All things work because energy enables matter to cycle and vice versa. Our claim is that energy needs matter to be created, and in order for matter to be cycled, organisms need to use energy. All of this is evident in the processes that take place in plants, animals, and in the earth.
One clear example of this is the carbon cycle because of its presence in all places around the world. Starting with plants, carbon will be taken in by the stomata. According to Crash Course Biology number 8, photosynthesis, during the Calvin cycle, plants use carbon dioxide to help fixate some RUBP, forcing the RUBP to break apart with the help of rubisco. This eventually leads to its reformation as G3P. After getting a bit of energy, the G3P can be turned into any carbohydrate or starch. Animals then consume this when they eat and use the glucose to produce ATP in cellular respiration. Carbon dioxide and oxygen are also cycled and needed in the creation of ATP in both plants and animals. The carbon atom, which is matter, is crucial for both creating and cycling energy. Energy would not be created if matter was not cycled and vice versa.
Another example of how energy and matter flows can be seen through other biochemical cycles, such as the phosphorus, nitrogen, and water cycles. Starting with the water cycle, water is an essential part of all and any life. Life simply cannot exist without it. Life is important to the flow of energy because without plants and animals, energy will not be able to cycle or flow at all. Another example, nitrogen, is responsible for creating a critical factor in photosynthesis. According to Encyclopedia Britannica, ammonia gets turned into nitrate in the soil. These nitrates are necessary to make chlorophyll. Without chlorophyll, plants would be unable to start photosynthesis and no energy would be produced. Lastly, the phosphorus cycle is directly linked to energy. Crash Course Biology number 7, ATP and respiration, explains that for energy to be attainable, it must be in the form of ATP. According to Paul May of the Bristol University, ATP is made of an adenine base, a ribose, sugar, and a phosphate chain. A phosphate chain is made of phosphorus, hence its name. We can see how phosphate is directly correlated with energy and literally makes up part of the energy compound. If the phosphorus cycle was not working and organisms were not able to get a sufficient amount of phosphorus, then it would be physically impossible to create usable energy.
Furthermore, evidence can be found in Albert Einstein's legendary Annus Mirabilis papers. Fen Flores from Stanford Encyclopedia of Philosophy state that in the papers, Einstein wrote how energy is equal to the mass times the speed of light squared, more commonly known as the equation E equals mc squared. Since mass is the amount of matter in a certain space, we can see that when there is higher amount of mass, there is more energy. This relationship between energy and mass show that matter and energy are directly correlated with each other. It also explains how energy and matter move as one fluid unit and don't just bump into each other by chance.
For our storyboard, we decided to base it off the carbon cycle. Let's look at the carbon atom, usually as part of a molecule, as it travels throughout Earth. Keep in mind that the carbon cycle does not necessarily have to occur in this specific order, it's just simply an example of how it could go. Let's start off with the atmosphere. Carbon dioxide molecules in the atmosphere are moved around by wind and convection currents. As though carbon dioxide gets close to Earth, the plant absorbs it through its stomata. The carbon dioxide is then fixated and turned into glucose through photosynthesis. Next, an animal comes by and decides it's time for lunch. The carbon is then transported into the animal. Unfortunately, the animal dies and carbon gets back into the soil via decomposition. Over the next million years, our carbon molecule is compressed with all the other carbon in the animal into fossil fuels. One day, a fat businessman creates an oil firm and drills up the fossil fuels to supply to the world. The fossil fuels are then burned to create electricity, and carbon dioxide is released as a byproduct. As the carbon dioxide once again explores the vast wonders of the atmosphere, phytoplankton use the CO2 in their own photosynthesis. Suddenly, Nemo comes along and decides it's time for lunch, and when Nemo eats the phytoplankton, the carbon is now passed on to him.
6.5 hours later.
Human comes along and decides it's time for dinner. He goes out into the sea, catches Nemo, and eats him. Naturally, carbon is now passed to the human. Inside the human body, the carbon is used in cellular respiration and comes out as carbon dioxide. The carbon is released back into the atmosphere where the process can start all over again.
Living things which are made of matter require energy to be able to perform basic functions and to thrive in ecosystems. Organisms rearrange matter to create energy and use energy to cycle matter. Through the many different biogeochemical cycles, matter is reformed and rearranged using energy, allowing the proper matter to be distributed properly throughout the Earth. In an ecosystem, one cannot cycle without the other, representing the importance of energy and matter. Organisms are made of matter that need energy to function. Together, they are able to create the basis for a thriving ecosystem.